We have learnt about the first derivative test in your previous lecture on maxima and minima. Now today we will see about the second derivative test for this maxima and minima. So first of all, I would like to suggest you to follow some of the steps by which we can apply the second derivative test to find the maximum and minimum value of a given function. Let us see what steps we will follow to test that a given function is when maximum or when minimum and what are their maximum and minimum values. For this, let us consider that we are given a function f of x. Okay. So when a function is given in your problem, your first step will be to find the first order derivative of the given function, that is f dash of x. It means you have to differentiate the given function f with respect to x, and after that you will get the first order derivative f dash of x. Okay. Now after getting the first order derivative of the given function, our second step will be to find the critical points of the given function, and you have already learned about finding the critical points. And you know, for getting the value of critical points, we have to equate this first order derivative equal to 0. So in second step we will simply put f dash of x equal to 0, and then we solve the equation, and solving the equation you get the different values of x which are actually the critical points of the given function. Now let us consider among all those critical points, one of the critical points is x naught. Okay. Now you have to test that at x equal to x naught the given function is maximum or minimum. Okay. And for this you have to find the second order derivative. So after getting the critical point, we will find the second order derivative, that is f double dash of x, and for getting it you have to differentiate f dashed with respect to x. So differentiating f dashed with respect to x, we obtain the value of f double dash of x. Okay. Now once you know the second order derivative, now you have to put the value of x equal to x naught, and you have to see what values we obtained after substituting the critical point x naught at the place of x. Actually in this case there will be three situations, or you may will be encountered by the three types of values of the second order derivative. So when we obtain the value of f double dash of x, and we find what is this f double dash of x when x is equal to x naught. Actually I have written it like f double dash of x naught. Obtain the value of this, and after obtaining the value of this f double dash of x naught, if the value is less than 0, that is negative. I have mentioned it here. You can see that if f double dash x naught is less than 0, which means this is negative, then you can say that at this critical point x equal to x naught, our function has a local maximum value. This is just this just sounds like opposite, because the result is negative, but you have to say that when the second order derivative of function f of x at the critical point x equal to x naught is negative or less than 0, then that critical point corresponds to the maximum value of the function. Okay. But if you find the second order derivative, that is f double dash of x, and again you put x equal to x naught, that is you obtain the value of f double dash of x naught, and this value, if it is greater than 0, that is positive, then that x naught corresponds to the local minimum value of our function. So f double dash of x naught when is greater than 0, that is positive, then x equal to x naught is a point of local minimum. Okay. But sometimes it is also seen that when you obtain the value of f double dash of x when x is equal to x naught, then the result is 0. It means when you say 0, it means this is neither positive nor negative, because you know that 0 is a non-negative, non-positive number. So neither positive nor negative. Okay. In this condition, when the second order derivative of the function f of x at the critical point x equal to x naught is neither positive nor negative, it is simply equal to 0. Actually, in that very condition, the second derivative test does not give any conclusive result. It means you cannot decide that at this critical point our function is either maximum or minimum. Actually, in this case, you have to go back, which you have learnt in the previous lecture. It means you should try to find the maximum and minimum value of the function at this critical point by the use of the first derivative test. So you can say that when f double dash of x at x equal to x naught is 0, then our second derivative test fails, and we have to think about the first derivative test, and we can decide that our function has a local maximum or local minimum at this particular critical point by the add of the first derivative test. Okay, so I think this is a very simple concept, and this will be clear to you when you will actually solve some of the numerical problems. Then this concept will be clear to you. Okay. Now, once you have decided that your function is either maximum or minimum at a given critical point, then by simply substituting the value of that critical point, that is value of that x, in the expression of the given function, you find what will be the maximum value of the function and the minimum value of the function. Okay. So these are the steps which is actually followed to test that a function is either maximum or minimum. Okay. Or in other words, you can say to test the extremum value of function, we have to follow these steps in second derivative test. Okay. Now all these things which I have just mentioned here, that will be very clear to you when we will see some of the illustrative examples. So now let us see some of the illustrative examples here. In first example, I have taken a problem which says that find the points of local maximum or minimum for a function f of x equal to sine 2x minus x, where x belongs to 0 pi. It means the value of x lies between 0 and pi. This is a very simple problem. Following the steps which you have just learnt, you can easily find that this function will have a local maximum or minimum value at which point you can easily decide. See the solution. Actually, all the steps which I have just dealt, you can follow here. Your given function is what? You can see our given function is f of x equal to sine 2x minus x. Okay. What I have told you, once you know the function, first of all we will find the first order derivative of the function. So simply differentiate this f of x. So Derivative of f of x with respect to x, I have denoted it by f dash of x. And what will be that? You know, the derivative of sine 2x, that will be simply 2 cos 2x, and that of x will be 1. So f dash of x is equal to 2 cos 2x minus 1. Okay, this is the first order derivative of the given function. Now in the second step, I have told you that first of all, now you have to find the critical points. And for getting the critical points, what you do? You have to equate this f dash of x equal to 0. So for getting critical points, I am just equating f dash of x equal to 0. But f dash of x, you have seen in this equation 1 that this is cos 2x minus 1. So this 2 cos 2x minus 1, this is equal to 0. Okay. And so 2 cos 2x will be 1 and cos 2x will be 1 by 2. Now you have to find the value of 2x when cos 2x is 1 by 2, but that value must lie between 0 and pi. And you know that those values will be pi by 3 and 5 pi by 3, because cos pi by 3 and cos 5 pi by 3 both will be equal to 1 by 2. And so that x will be pi by 6 and 5 pi by 6. So these are the critical points. We have obtained two critical points. These are the values of x naught. X naught are actually, first x naught is pi by 6 and the another x naught is 5 pi by 6. Okay. So after getting the critical points, what will be now we will do? Now we will have to find the second order derivative of our given function. As already we have obtained the first order derivative, so when you will differentiate this first order derivative f dash with respect to x, that is df dash of x by dx, then you will get f double dash of x. And you can see f dash of x we have obtained, this is 2 cos 2x minus 1. Okay, now differentiate it. You know the derivative of 2 cos 2x, that will be minus 4 sin 2x, and that of 1 will be 0, so I have not written it here. So the second order derivative of the given function, that is f double dash of x, is equal to what? This is minus 4 sin 2x. Okay. Now we will find the value of this second order derivative of our function at these two critical points. Okay. So now let us find f double dash at x equal to pi by 6, because pi by 6 is the first critical point. Okay. So what you will now do? We will simply substitute pi by 6 at the place of x. So you can see this will be minus 4 sin 2x, but x is not pi by 6. So this is minus 4 sin 2 pi by 6, and this 2 will cancel and here there will be 3. So this is simply minus 4 sin pi by 3. But sin pi by 3, you know, this is root 3 by 2. Sin pi by 3 means sin 60 degree. And so you can see that this 2 will cancel and here there will be 2. So f double dash at pi equal to 6 is equal to what? This is minus 2 times root 3. You can see that the second order derivative at this first critical point pi by 6 comes out to be negative. So you can say that this f double dash pi by 6 is less than 0. But what you have learnt? You can see when f double dash of x naught is less than 0, our function has a local maximum at this critical point. So you can easily say that this function f of x will have a maximum value at pi by 6. This is one of the answers, because in our question it is asked to you that locate the point where your function is maximum and minimum. Now let us put the value of second critical point in this second order derivative. So f double dash of pi by 6 will be what? Again, in this equation 2, at the place of x we will now substitute pi by 6. So this will be minus 4 sine 2 times pi 5 pi by 6. Okay, and this will be minus 4 sine 5 pi by 3. But sine 5 pi by 3, this is minus root 3 by 2. Minus root 3 by 2. And so this minus minus will become plus, and so f double dashed at 5 pi by 6, this is 2 times root 3. This is positive. You can see your result is positive. Okay, and if your result is positive, see here that when f double dashed of x naught is greater than 0, that is positive, then our function has a local minimum at this critical point x naught. So you can easily say that when x is equal to 5 pi by 6, then our function will have a local minimum value. Okay, this will have a local minimum value. I have mentioned it here. You can see that f double dash or 5 pi by 6 is greater than 0, and this result implies that f of x is minimum at x equal to 5 pi by 6. So you can see after the solution of this problem that how we can obtain the point of local maxima and local minima by the aid of the second derivative test. Okay, I hope you have a clear picture of the concept now in your mind. Okay, for more clarification, I am taking here another important example. Let us see. The second example says, find the points of local maxima and minima and the corresponding maximum and minimum values of the function f of x equal to this much. This is your function. Okay, question is same, function is different, but problem is not different. Only extra thing is here that we have also find the maximum and minimum value of the given function. Okay, so one step will be larger in comparison to the first problem. Now again you can see your given function f of x is equal to this much. I am not giving the reading, you can see it here. As I have told you, first of all, we in first step we find the first order derivative of this function. So let us differentiate this f of x with respect to x, and that derivative is denoted by the symbol f dash of x. Okay, now this is a very simple differentiation using the formula dx to the power n dx equal to nx to the power n minus 1. You can differentiate each and every term. So you can see the first the derivative of first term will be what? That will be minus 3 by 4 times 4x cube. So the second the derivative of second term will be what? This will be minus 8 times 3x square, and that of the third term, this will be 45 by 2 times 2x. But 105 is a constant, so its derivative is 0. Okay, so you can see that f dash of x is now equal to what? This is minus 3x cube minus 24x square minus 45x. Okay, now you can see this minus 3x can be taken as a common factor in RHS. So when we will take minus 3x as a common factor, the remaining factor will be x square plus 8x plus 15. Okay, so in this way we have obtained the first order derivative of our given function. Now to find the critical points, what you will do? We will simply equate this f dash of x equal to 0, and then we obtain the value of x, which gives the critical points of the given function. So I have actually simplified this expression to some extent here. You can see that inside the bracket the expression is x square plus 8x plus 15. So when you will actually factorize it, you can write it x square plus 5x plus 3x plus 15. Now in the first two terms we can take x as a common factor and the remaining factor will be x plus 5, and in the second two terms we will take 3 as a common factor. Okay, and your result is like this. So f dash of x, you can see from here, can be written as minus 3x times x plus 3 times x plus 5. This is the value of f dash of x in simpler form. Now for getting the critical points, we equate f dash of x equal to 0. But f dash of x as defined in this equation 1 is this much. So we substitute here the value of f dash of x, and this is minus 3x times x plus 3 into x plus 5 is equal to 0. Since minus 3 is not 0, so you can write x times x plus 3 times x plus 5 equal to 0. And from here you can easily see that x will be 0. Again you can write x plus 3 equal to 0, and so x will be minus 3. Again we will equate this next factor x plus 5 equal to 0, which implies x is equal to minus 5. X equal to minus 5. So in this way you obtain x equal to 0, minus 3 and minus 5. So there are three critical points of the function in this problem. Now to find the point of local maxima and minima, what now we have to do? Definitely you can remember, now we will have to find the second order derivative of the given function. But since we have already obtained the first order derivative, so for getting the value of f double dash of x, we simply differentiate this f dash of x with respect to x. So f double dash of x is df dash of x by dx, and so this will be d dx. And you can see that this f dash of x is equal to this much. See here, I have actually multiplied by this x to the terms inside the bracket. So this is minus 3 times x cube plus 8x square plus 15x. Because in this form differentiation will be easy, so I have written the value of f dash of x in this form here. Okay. Now let us differentiate it. Since minus 3 is a constant factor, so it is outside of the operator, and differentiate this expression. You can easily see what will be the result. This will be 3x square plus 16x plus 15. Okay. Now we obtain already the value of the second order derivative of our function. Now we have to substitute the value of x equal to 0, minus 3 and minus 5, and we have to see the value of this second order derivative when x is 0, when x is minus 3, when x is minus 5. Then what is its value? It is either positive or either negative. Okay, so you can see, first of all, in first case I am considering x equal to 0, and then we will find the value of f double dash at x equal to 0. You can see this is expression for f double dash of x. When you will put x equal to 0, this term 3x square will be 0, 16x will be also 0, only this 15 will remain inside the bracket. So that will be 15 times minus 3, that is minus 45. So what you are seeing here, f double dash of x is negative, that is less than 0, when x is equal to 0. X is equal to 0. And we have learnt that if second order derivative is negative at x equal to x naught, then the function has a local maximum value at x equal to x naught. Here x naught is equal to 0. So you can easily say that our function f of x has a local maximum at x equal to 0. Now in this problem, we have been also asked to find the local maximum value or minimum value of the function. So if your now aim is to find the maximum value of the function, what you will do? You have to put the value of x equal to 0 in the expression of f of x. And what is the expression of f of x? You can see this is the expression of f of x. When you will substitute x equal to 0, this first term will be 0, second term will be 0, third term will be 0. Only this 105 will remain non-zero. So the value of the function when x is 0 is 105. And as we have obtained that at x equal to 0 our function is maximum, so this is actually the maximum value of our function. You can say local maximum value. This is not global maximum, this is local maximum. Okay. So at this critical point our function is maximum and its maximum value is 105. Now the another critical point is x equal to minus 3. Okay. So to check that at x equal to minus 3 the local maxima or the local minima which exist, we have to put the value of x equal to minus 3 in the second order derivative. That is f double dash of minus 3 is what we have to see. Now let us see. Since f double dash of x is this much, we will substitute x equal to minus 3 in this expression. So here at the place of x we will put minus 3. Also here we will put minus 3. Okay. And substituting this, you can see your result will be what? This is minus 3 times 3 into minus 3 square plus 16 into minus 3 plus 15. Okay. And this will be minus 3 times 27 minus 48 plus 15. Okay. And that will be minus 3 times 42 minus 48. And so this is minus 3 times minus 6 and that will be 18. So you can see that f double dashed at x equal to minus 3 is 18 and 18 is a positive number. So it is certainly greater than 0. But you have learnt that if the second order derivative is positive, then the function has a local minimum value. So you can say that our function f of x will have a local minimum value at the critical point x equal to minus 3. Now you can easily find what will be that minimum value. For this you have to put x equal to minus 3 in the expression of fx. So f minimum is equal to f of minus 3. And the expression of f of x you have seen here in this you can see. So at the place of x now we will substitute minus 3 everywhere. And your result will be what? You can see this will be minus 3 by 4 minus 3 to the power 4 minus 8 times minus 3 to the power 3 minus 45 over 2 times minus 3 square plus 105. Actually after simplification you will get that it is 231 over 4. So this is the minimum value of our function. Okay. Minimum value of our function. Okay. Now the third critical point you have obtained is x equal to minus 5. Now at this x equal to minus 5 we have to test that our function is either maximum or minimum. And for this, again in the similar manner, we will substitute x equal to minus 5 in the expression of f double dash of x. And so when you will substitute this, then you will get that f double dash at minus 5 is equal to minus 30. You can see this calculation. Okay. And minus 30 means less than 0. And you have learned that if f double dash is less than 0, that means the function has a local maximum value at that critical point. So at x equal to minus 5, our function has also a local maximum. So you can mark this function has a local maximum at x equal to minus 5. And it has, you have also seen in first case that it has a local maximum at x equal to 0. So don't be confused. A function may have any number of local maxima. Global maxima is one and only one, but local maximum may have more than one values, because when you talk about local maximum, that maximum value is compared with the value of our function with its at the points in its close neighborhood. So this is a local maximum. Okay. And if your aim is now to find this local maximum value of your function, you have to substitute x equal to minus 5 again in the expression of f of x. And I have directly written the value. You can simplify it. That will be equal to 295 over 4. So after this problem, I hope your concept has been some more clarified. Okay. Now I am taking a very important example which has been asked in a very prestigious examination, which is IIT JAM in 2007. This was a question in the form of multiple choice. So I have written this question in the same fashion in multiple choice form, MCQ form. The question says that let f of x equal to x cube minus x square plus 1, where x lies between 0 and 1. It means 0 is less or equal to x and it is less or equal to 1. Then the absolute minimum value of fx is what? There are 4 options you can see, and you have to select the correct option. That is, you have to find the absolute minimum value of this given function, and then you can choose the correct option. The problem is same. A function is given and we have to first of all locate when this function will be here. Actually only the minimum value has been asked to you, so we will not talk about the maximum value. Okay, let us see. Our given function is this much. F of x is x cube minus x square plus 1. And you know, first of all, we will obtain its first order derivative. So f dash of x will be what? That will be 3x square minus 2x. Because 1 is constant, its derivative will be 0. But you know, if our function is either maximum or minimum, then its first order derivative is 0. Okay. It means we are going to find the critical point. And for this, we obtain the critical point by equating f dash of x equal to 0. But f dash of x you have obtained is this much. So we will write 3x square minus 2x equal to 0. Now take this x as a common factor. X times 3x minus 2, this is equal to 0. So since the product of two factors is 0, so we can equate both of the factors equal to 0. So one value of x will be 0 and the another factor 3x minus 2 will be equal to 0, and so that x will be equal to 2 by 3. So you can see there are two critical points. First one is 0 and the second one is 2 by 3. Okay. Now to know about the fact that our function is either maximum or minimum at x equal to 0 and at x equal to 2 by 3, we have to actually obtain the second order derivative. And for getting the second order derivative, that is double dash of x, you have to differentiate this f dash of x. Okay, so you can see f double dash of x is df dashed by dx, and this is d dx, and f dash of x is this much, that is 3x square minus 2x. So f double dash of x, this is 6x minus 2. Okay, now let us put the first critical point x equal to 0 here. So f double dash at x equal to 0, what will be this? Put here 0. So 6 into 0, that will be 0, a minus 2. So f double dash at x equal to 0 is minus 2, which means it is less than 0. And if it is less than 0, you know, then the function f of x will have a maximum value at x equal to 0. But in this question, we have been asked to find the absolute minimum value of our function. But at the first critical point, you can see our function is not minimum, it is maximum. So you can guess that it is possible at the second critical point, which is x equal to 2 by 3, it is possible that the function will have a minimum value. Let us check. For this, we will find f double dashed at x equal to 2 by 3. So at here, at the place of x, now we will substitute 2 by 3. So this is 6 into 2 by 3 minus 2. And this will be 3 times 2, so 4 minus 2, and that will be 2, which is positive, that is greater than 0. So you can say at this critical point x equal to 2 by 3, our function f of x will have a local minimum value. Okay. Now it is known to you that the given function is minimum when x is equal to 3. And now you have to obtain the minimum value of the function, for which what we will do? We will simply substitute x equal to 3 in the expression of f of x. And you can see f of x is equal to what? You can see your expression for f of x. This is actually f of x. You can see this is x cube minus x square plus 1. Okay, this is x cube minus x square plus 1. But we have already find out that at x equal to 3 our function is minimum. So when you will substitute x equal to 3, minimum at not 3 but 2 by 3. 2 by 3. We have obtained this value at x equal to 2 by 3, not 3. Okay. So we will put x equal to 2 by 3 in this expression. So at the place of this x and this x, let us put 2 by 3. So f at 2 by 3 is 2 by 3 cube minus 2 by 3 square plus 1. And after simplification, you will get that this value is f of 2 by 3 is 23 over 27. Okay, you can see the calculation here. So now you can see your option. In our option, this 23 over 27, I have actually written here wrongly. You can see here will be 23 over 27. So actually our third option is correct. Okay, 23 over 27. So third option is correct. Okay. So I think after this video, if you have watched the video seriously, definitely the concept of maxima and minima by the use of second order derivative test will be definitely clear to you. Okay. So Watch the video seriously and wait for the second lecture for the new concept of maxima and minima in the further coming video. Thank you very much.